Okay, hello and welcome. I'm Mark Kromer, and this is Anexinet Big Data in 10 minutes. In the next 10 minutes, I'm going to introduce you to solutions for big data analytics from Anexinet. At Anexinet, we are a leading IT service provider for both software and hardware in the Philadelphia region. One of our big focuses is business intelligence, data warehousing, and big data. I'm going to talk to you today a little bit about big data, what it is, and what we do to provide big data solutions at Anexinet. So let's get started, and we'll kick things off with an intro to big data, some big data 101 or big data defined. When we talk about big data, you'll hear a lot of talk about the three V's. They are volume, velocity, and variety. And what that means is really this is a way to differentiate what big data is, to help to explain it, versus non-big data or normal data, I guess that would be, or data that's not big. And what's interesting about that is that we're sort of at an inflection point, in my opinion, in the database industry right now, where a lot of the technologies that came out of Silicon Valley from Yahoo and Google and some Facebook and up in Seattle with Amazon, things like NoSQL and Hadoop, those are really changing the terms in how we are able to process and analyze large data and complex data sets. And that's where this idea of big data comes from. Amazon has their Dynamo database, and from that came things like Cassandra, and then Yahoo with Hadoop, and Yahoo in fact broke off a lot of the team from their Hadoop team and started a company called Hortonworks, which has a distribution of Hadoop. But I don't want to get too techy in this conversation. I just want to talk about what we can do for you in your business here at Anexinet for big data. So coming back to the three V's, and notice I have four V's on this slide, and I'll get to that in a minute. But essentially, that's volume, velocity, and variety. And what we're talking about here is that the scale and the magnitude of data is on the scale of terabytes, petabytes, and zettabytes with big data. Essentially, these are data sets that are probably going to be too large for your classic OLTP databases, and probably too much data coming in, which is sort of the velocity idea here, coming in too fast, such that it'd be difficult for your ETL nightly batch processes to process all the data. And then the variety is that, well, those database concepts I talked about earlier, like Hadoop and HBase and Cassandra and those NoSQL databases, are not rigid schemaized databases. They are the idea of getting lots of data and being able to slam that into some kind of a data store, the key value store, JSON documents. HDFS is the file system for distributed file system for Hadoop, for example. Get all that data out there as quickly as we can, and we'll worry about schema and consistency later. And so with being able to handle a variety of different kinds of unstructured data is very important, and a concept that big data approaches to these problems enables you to take in data from sources like social media so that you can figure out who's saying what about your products, and you can understand what people believe, your customers believe are good and bad about them. You do that through text analytics against things like Twitter and Facebook and Google searches. And then I add value at the end there, or another V to this list, because that's what, in my opinion, big data analytics does, is that allows you to grab extra value out of that data that you didn't have in your business before, so that now you're improving your ROI and you're improving your, let's say, for example, you're getting uplift in your marketing campaigns now because you have data points that you didn't have before, and you're now able to analyze your customers in ways that you couldn't before. And so now your marketing campaigns can be targeted, so you can do customer segmentation and all kinds of customer analytics that wasn't possible before. But continuing on that theme of the origins of these concepts of big data, I have some examples of Yahoo at the bottom, and then I also want to talk a little bit about finishing up that idea of what's different between data warehousing today and big data. And in my mind, big data is not a replacement for a data warehouse in most cases. So the big data projects I've been involved in have all, in every case, also had enterprise data warehouses, or had MPP or massively parallel processing databases involved in them. So that's usually been the case. Now, sometimes some of these Silicon Valley internet companies that originally worked on NoSQL and Hadoop, probably wanted to minimize their licensing costs with Oracle and those sorts of things and Teradata. And so some of those things were probably replaced with Hadoop and NoSQL. But for the customers that we work with here at Anexinet, the enterprises outside of the search engine industry, the architecture, I'm going to have a slide on that in just a minute, is going to be including a lot of your common data warehouse and BI technologies. And what Hadoop and big data becomes is a way to process the rest of the data in your organization that essentially is sitting there providing no value to you, instead just costing you money with your storage vendors, but you're not getting anything out of that. And so that's what sometimes is referred to as exhaust data, or the data that is not being put into your data warehouse. I mean, I remember a lot of the numbers that come out of organizations like TDWI around enterprise data warehouses, where the common number is that is that the estimate of maybe 10 to 20% of your overall organizational data assets are available to you in your data warehouse. And even when you do have a nice set of data in your data warehouse, it's aggregated, summarized data. And so the really sharp analysts in your company, the ones who are the data scientists, they're not able to glean new business value out of that. They need to get down and drill down into the raw data, and that you can store in a key value database, and you can store that in a distributed file system like HDFS, and give them access to it through tools, like Hive, for example, which is a way to run data warehouse style queries against that raw data. And finish up the slide on the Yahoo scale and example. And I like this example because here at Anexinet, we also work with the same technologies that Yahoo used for their big data, which is Hadoop and SQL Server and Oracle and Tableau. So Yahoo uses SQL Server analysis services, Hadoop, Oracle, and Tableau. They have a 2 petabyte Hadoop cluster of many, many nodes distributed across a whole bunch of different Hadoop clusters. Now, in many cases, you're not going to need that many. You're not going to be on that scale, but this does show you a key value point of big data in Hadoop in particular is that ability to use distributed processing of MapReduce and HDFS, and to be able to store that data in blocks across distributed nodes without shared storage. And this way you can take these very large files and data sources and process them, because it's the divide and conquer technique, and the idea of having data locality where you're working on your own separate data sets, one node at a time, in parallel. And so then the cube, they also use Oracle RAC, and then the cubes that they have for analysis services produce in the neighborhood of 24 terabytes of data each quarter. So these technologies work for this kind of a concept, and when you think about it from a high level, this is sort of what a reference architecture for a big data scalable platform would look like. You can plug in different technology vendors, and here at Anexinet we partner with the major ones in this space: HP, with Vertica, EMC and Greenplum, Microsoft with Parallel Data Warehouse and SQL Server, and Oracle, of course, with Exadata and Exalytics. And going left to right, you have the Hadoop framework, which is an open source Apache Hadoop framework, and that has the MapReduce and the clusters in it. And then notice I have data warehouse in there, so you could aggregate the data and keep it stored in the raw form over in Hadoop, and then put those aggregates coming out of your MapReduce into your enterprise data warehouse in your star schema. And you can, or have an MPP massively parallel processing database there that is meant just for your big data and your analytics. So when you move over to the analytics pillar, you should be utilizing the technologies available to you, like in-memory and column stores. And the reason for that is because the data is in such large volume that you want to make sure you can compress the data and that you can aggregate it and access it quickly. And the only way to really do that effectively, in my experience, has been using technologies like in-memory and column store. And another example is a database from Teradata. They bought a technology called Astrodata that also has analytical functions right built into the engine that distribute using MapReduce across worker nodes, and that is a very effective way to be able to get big data analytics out of these kinds of solutions. And then finishing up all the way at the right, you're going to have your analytics available to your analysts in your business as well as your data scientists for ad hoc data discovery. And that's where you really get into the fun of big data, where your data scientists are now discovering new patterns in data. They're able to find out what people are saying about your products and making better decisions based upon that data. And at the end of the day, you start to see things like what I have on this slide, which is some examples of what big data actually looks like when you visualize it. It's a little bit different than the classic, balanced scorecard BI dashboard, because here we're providing analytics that a data scientist is going to need to get access to, and you're going to have millions of data points in many cases. So you're going to want to see things like heat maps and clouds and chords and sand keys, because you want to see how do these million attributes relate together all the way over at the right hand side, like in this example here from Google Analytics. Kind of a concept is, how do all these different things work together, and how does one thing affect the end result more than another? Those are the answers those are the questions that we're providing answers to in big data analytics. So think about how this could be helpful to you, not just in marketing and in customer analytics and in web analytics that I've mentioned already, but also things like, if you're a communications company and you need to get data off of network equipment, which is producing just millions of messages a day on that, and you want to get some network analytics out of that, and you want to see how does one router or one switch affect service in a specific area. And to get that kind of correlation and root cause analysis, you need to get diagrams like this, as opposed to a BI solution, which is more around daily, weekly collecting of financial data and that kind of thing. This is where big data comes in very, very importantly. All right, so wrapping up here, 3 specific areas that we are very good at Anexinet for big data solutions. A strategy engagement, so we can work with you to help you to define your big data strategy, make sure that you're on the successful path to providing value back to your business with a big data project. We use our experts in data warehousing and big data and BI to define that for you and deliver you a strategy and a roadmap out of that. A starter solution is when you're ready to get started and you want to make sure that you can have a POC and a pilot that at the end of the day is showing some analytics and actual value back to your business, so that the ROI and the payback is clear and defined. And that's what a starter solution will do for you in a very rapid turnaround time. And last but not least, of course, we're here as your technology partner to provide a end-to-end big data project engagements, including data discovery and visualizations. And then those last slide here, those technology partners that we generally work with in the big data space at Anexinet are these partners of ours, which is EMC Greenplum, HP Vertica, Microsoft with PDW and SQL Server, Oracle, their Exalytics and Memory Analytics, the Oracle Big Data Appliance that includes Hadoop. I believe that's the Cloudera distribution of Hadoop, along with their NoSQL database. QlikView for visualizations. Tableau is very good for visualizations as well. And of course, Microsoft has in-memory data visualizations and Power Pivot and Power View as well. All right, so that was a rapid fire 10 minutes on big data solutions from Anexinet. Thank you for joining me, and we'll talk next time.